but so hopefully we'll have a bit of time at the end. Hi everyone, I'm Alex Reynolds, senior engineer at Arcadis. Just recently passed my incorporated engineer status with the PWI, which I'm very happy about. And I'm here to present today on the Gosforth Depot remodelling. So the project overview. So the project was to remodel the existing maintenance depot up in Gosforth, which is in Newcastle in the northeast, as a project for Stadler Rail, with the main building contractor being Volker Fitzpatrick, and Arcadis serving as the main designer for track, OLE, and civil aspects with architecture as well. So it was an interesting one. The layout at Arcadis we took the design itself from concept, early grip 3, sort of tender phase, all the way through to commissioning, which it was commissioned at the beginning of this year in February, with the depot actually being the new maintenance building being in use for maintenance work for much longer than that. It was under use during some of the main construction phases of the build, which added to some of the complexities of the design and staging of the depot that I'll talk about later. The project remit that we were looking at for it was obviously to replace the old building and sidings which had been in use for about 100 years, I think, all in. So there's been a depot on site there for at least a century. So the aim of the project was to replace with a new maintenance facility, offices, upgrade the signalling and control room, provide an underframe cleaning facility, carriage wash and wheel lathe, and a stabling capacity within the depot for 49 of the new Class 555 Metro fleet from Stadler. So just as an overview, you can see here with the location, we've got some main challenges around the site. So throughout the staging, the and build of the new depot, we were required to maintain at least 35 vehicle stabling capacity of the existing Metro car, which is the Class 59, on the depot, so that they could continue being maintained and provide service to the Metro system of Newcastle, so that we were not impacting the day-to-day operation as much. There was a satellite depot built at Hebden, I believe, to alleviate some of the capacity, but the main capacity of stabling and maintenance was to be done on site throughout. The western side of the depot, which is here, so you've got west, east, as shown on this layout plan, is through the existing wash, which you can just see here, was a falling gradient of 1 in 80. So we had quite a steep gradient coming in, which created quite a significant level difference between the relatively flat main lines along here and the lines coming into the depot that were falling. So that led along this southern boundary as well to have quite a good sized embankment and retaining wall, which hemmed in the southern side of the site along here. Around the north end, we also have a requirement to maintain and keep an avoiding line. So the avoiding line sort of allows trains to come from the airport, which is to the west of the depot, and bypass without a reversing move at South Gosforth here, and just bypass. Now, as part of that, there was an aspirational requirement to dual that line, single track 20-mile-an-hour line that runs around there, and in the future there is a plan to dual that to improve it and bring it into more mainline capacity for those west to east to west moves. So within our original feasibility, we had to do a potential alignment that would dual that and look at how that junction interface with the reception roads of the depot would interact. The infrastructure throughout was also quite a big challenge. It was a mixture of bullhead and flat bottom, both rail and S&C of varying ages and wear and use also. So understanding where these differences were and understanding how we would tie into them during our staging of the design was key to ensuring that there were no issues with componentry interfaces between proposed and existing. So a lot of you may be aware, but for those that are not, there's Nexus, who is the maintainer and operator of the railway and the Tyne and Weir, has their own track constructions and gauging standards, which we were working to, but a large proportion of those also refer back to Network Rail. So during the design and build, you are working to two sets of standards, a mixture between Network Rail and Nexus. Just briefly, software, as things are changing, coming up with the outlook of Open Rail Designer. This was based in Bentley Railtrack, with our coordination and clash detection done with ProjectWise, and all clearances done on Clear Route 2. Yeah. So, as I said previously, the original depot was a mixture of flat bottom and bullhead, which was all to be ripped out and replaced. The plain line areas were replaced with new SEN 56. However, within the depot, the maintenance shed itself, we had some sections of pedestal track, which was required for maintenance, for specific maintenance operations. So with those tracks, due to the interval between those for access requirements, we had SEN 60 rail on those due to the wide spacings on the pedestals, to alleviate any deflection in the rail. Track was jointed throughout, so unstressed jointed track, but it was welded up within any embedded sections to reduce the maintenance requirements within the shed and things. The original Form A looked at replacing all with new G44s throughout. However, later on, in detailed design and value engineering, we undertook an embodied carbon assessment of the overall site and found that using serviceable F27s and F40s throughout instead would be a valuable saving for the project. So that was implemented. This also allowed a similar clip type, which negated additional training for the on-site maintenance team, which was a bit of a benefit for the client. So that's the difference between using the pan pullers for fast clips on the G44s and the clips for the clip removers for E-type or PR 401A clips on the F27 F40s. The S&C was non-new concretes to reduce the use of hardwood bearers as the composite sleepers at the time of design and construction were not fully approved. So the concrete standard unit was implemented for the depot, and you can see the picture there just sort of shows the one of the lines going off towards the west with the installed new ballast walkways and the I think those are F27s sleepers in there. So the design itself, how did we get from the top picture on the left where you can see, so it's approximately a 7-acre site with the shed dominating most of that, as you can see in that top image from Google Earth. So the main facility shed is really dominates, and we reduced that with a more modern building, a much more energy efficient building, into the image that was courtesy of Volker Fitzpatrick on the bottom, with our top sardings, our main stabling sardings all the way throughout. We've got the wash plant here, wash plant. We've got the wheel lathe here, the UFC, and the main facilities building. So you can see the overall building size from has been drastically reduced. So how did we get there? Well, as I just sort of alluded to at the beginning, we had to make sure that we could provide maintenance all the way through the build. So we chose a staged approach to phase the demolition and construction. This allowed for the main facilities building to still stay active for a number of vehicles and maintain as much stabling capacity on existing depot that we could throughout. So this we rolled through from south to north, as you can see there, labelled stage 1 to 5, sorry, with the main construction and demolition stages. This was sort of facilitated by the construction of the building. As you can see here, these corrugations align up with internal walls, allowing the roof to be removed in sections, which is sort of most notably here. You can see where we split between stage 3 and stage 2 with a removal down the building. The existing site is OLE, it's 25 kV DC, which is a bit different to mainline network rail track. So there was some interesting work done by the OLE team to create temporary anchors for that during the staging. At the same time, as you can see, we've sort of cut the building in half here. So the work we were looking at was mainly trying to minimize disruption to the overall metro and the ability to service passengers on the metro lines. So the approach that we used here really minimized that, with only 2 disruptive processions required in order to do that. Now, this East End was one area where we were required to adapt the design midway through construction. So in the original Form A, we looked at we had a single road access reception road here, with a new crossover being installed on the main lines. However, during this was inner part to allow for staging. As you can see here, you've got some intricate staging requirements in order to make that work. However, with the interface with the main lines here, the signalling aspects of this were highlighted later on to be more complicated, as it would require mainline signalling and much greater disruption to the main lines. So this was requested and amended to try and look at a dual reception and arrivals and departures road, which we looked at and managed to make work with the design as was, with minimal disruption to the overall program. In the end, this ended up being a 72-hour possession, so one big blockade, and install the entire eastern reception roads, which then tied in to the temporarily tied into the existing depot to allow for vehicles to depart again from the east following the works. Now, I'm aware there's a lot of this that I am I'm skipping through. It was a very complicated project, but I'm aware that it's a lunch and learn. I could probably do a good long couple of hour presentation on this one. So please pop any questions as I go through in the chat. I'm happy to discuss at the end. So what would we do differently with the project? So the 3D modeling of componentry, I think within the track discipline in the past, we've sort of been not as forward thinking as we could be with regards to how we fit into the overall BIM world, with our 3D modeling usually, providing line strings which just get dropped in a model, but then there's no real context around there as to how that interacts with our track componentry to the wider civils world. So moving forward, and this is something that I'm driving within future projects and trying to learn more about, is modeling track componentry in 3D, such as sleepers, point handles, to really feed into the clash detection model. And it gives an instant sort of direct look during clash detection or IDCs as to where our assets are in the world without having to back work it from measurements, etc. Within our drawing development as well, it's our world for track is usually 2D with a horizontal and a vertical schematic in 2D, which is then requiring the reference of 3D assets from other disciplines, which leads to extremely large PDF sizes, which can be difficult for the client to open. So as we'd go forward, I would be looking to minimize this using 2D references from other disciplines to show their position in plan, and then using the 3D model for clash detection, etc. in that 3D space. We did this very well on the project, engaging with the construction team, having a good working relationship, but moving forward, I would engage earlier and try and work with them in the development of any staging work or and design to minimize disruption in construction, which may require adjustments later on site, and so to try and make the construction as easy as possible and get that built into the design early on. And the second would be to utilize the use of other staff for for other work. I led a large proportion of this, and I could have I was a bit I could have done better with delegating some of these works to other people within the team, to take the workload off myself within the project. I think that's something that I would look at definitely in the future. Yeah. And I know, I apologise for the speed, but it's either a very short presentation or a very long one, and I am aware it's a lunch and learn. Hopefully, I can do a much more detailed one in the future. But if there are any questions, happy to field those now, and I'll try and pull some images up in the background for the finished depot of how it looks now.
Yeah, that'd be useful. Thank you, Alex. Yeah, no, I think you definitely give us a flavour of the works, if nothing else. But yeah, you can always add a bit more detail in future. Don't worry about that. Is there any questions from anyone? I've penciled a couple to myself, but hands up. Anything in the chat?
Deathly silence.
Well, I'll make a start if you don't mind me asking a few. If
No,
that's
yeah,
okay,
fire away.
Alex. Did you have any deviations to standards? You noted you said quite a steep gradient. Did that cause you any issues?
So the issue was in relation to the S&C fan of the proposed alignment. So with the 1 in 80, if you left it as it was, you would end up with your vertical curve required. So the depot itself is obviously all flat for the stabling, but with that 1 in 80 grade, you would end up with your vertical curve right in the middle of your fan, so slap bang in the middle of all your S&C. So the design and around the spacing of S&C was required to position those specifically. If I go back to here, so you can see all this area through here is the S&C. So the only place that it really affects is against the is obviously you want to flatten that off to get it out, so that it's not within your S&C, but you're sort of limited. And then if you flatten it off too much, you end up with no stabling length of flat in front of your wheel lathe. So there was sort of a positioning of the S&C to allow space for a grade change between the units, which sufficiently flattened that grade off so that you had enough stabling length in front of the UFC for a full unit. Sorry, not the UFC, the wheel lathe, for a full unit coming into stable, as well as be flat within the building. So it was quite in the early phases of the design, there was quite a lot of detail in where those units were placed to allow a sufficient change in grade within the fan to give you all those aspects. And it, like I say, the real impact was against the wheel lathe building here.
Okay.
Yeah.
There's a question in from Felix. So, what was the strategy around the phasing of the works for the various fixed elements, e.g., the wash and the test track?
So we had the existing wash line that is on the main reception, and you can see it just off the picture here. So there's on the west end there's a single wash that's coming in. Now the problem with that position is that with the aspirational requirements of the dueling, there would be a second track directly adjacent to that, which would create no room for inspection personnel to access the backside against what would be considered the main lines. So the new wash was brought on depot there into this position that you can see. This allowed the existing wash to be used and throughout the construction phasing of the design. So the existing wash was in use all the way up until sort of final commissioning, and then it was decommissioned and all the brushes and things were brought over, upgraded, and brought into the new wash building that was here. So that's sort of partly how it was phased. It allowed the use of the existing wash all the way through the in its position, and then it was relocated later with the staging. So the actual wash building new was built, commissioned, and then the in line with the other one being decommissioned. Other buildings such as the main facilities building, about halfway through. So as you can see here, it's hard to see because without it, but the new building sits here at the end of stage 4, just before the beginning of stage 5. The new maintenance building was commissioned to allow all maintenance work for the old fleet to be brought into the new building, and then the rest of the old building was demolished, ready for the stage 5 works. So that was sort of the planning around how the maintenance would switch over it and things. So you always maintained that because the old Class 599s are sort of very much at their end of service life and need a lot of maintenance at the moment. So having the capacity to maintain them all the time was the reason for the new building being fully commissioned before the end of the old building being taken out of use. Yeah, I think hopefully that covers everything for that question.
Yeah, that was on the staging. I think Paul Walters
Yeah.
has got a
Yeah.
question in the chat, but I just go to on the staging. I'm surprised no one else has put this in the chat, especially from some of the schemes we're working on. Was there any issues with tying into the existing material and making sure there was no risk of kind of issues? Let's put it that way.
Yeah, so there was in the originals, in the beginning, it was sort of just ensuring that you had the correct wear. It was sort of the construction aspects of it, with regards to wear and differential wear between your new rail and your existing rail,
Right.
and rail profile. So ensuring that where we had the existing rail butting up to new, ensuring that we knew exactly the wear difference between the two rail types so that we could propose the correct lift plates, and with any differential wear being taken into account. They were some aspects of the poor geometry of the existing, requiring the tie-in aspects to be and allowances for sort of lift and slew to be greater than what you would normally have of your plus or minus 5 mil on the mains, but with the low speed and the risk assessment to that, it was acceptable to take that in for the temporary state, being that the temporary state between the two, with it being in use, would be a matter of weeks, not years. And then it would be replaced and taken out, and you'd be new on new in that case.
Okay. No, thank you. Thanks for that. Paul Walters has got a question in the chat. I don't know if you can see. Using SEN 60 rail, how much did this allow the supports to be further apart instead of using SEN 56 designed to cost? If I'm honest, Paul, I'm not quite sure where you're getting at. Do you know what he's getting at?
I think hopefully, please, Paul, jump in if
in
I'm
the
not
depot,
asking.
In the depot, you'll have had pedestals, will you not, where the vehicles are inspected?
Mm-hmm.
How far apart did that, using SEN 60, push them out as opposed to using SEN 56, because you've got a thicker beam etc. So you're saving costs in pedestals, etc.
Yeah, so the change was I think you could put them at about a meter almost with the the then 56 at most. So with the pedestal, it's because it's on a plate, the actual spacing centers is a meter, but the supported track is closer to what you would have on a maximum sleeper spacing of about 760, which can be upped to 1.5 meters when you use the 1060 rail. Now, this is because the units are much lighter than mainline stock. So the Metro stock is much lighter when and unladen, so there's no passengers or anything like that. So the deflection is significantly less than what you would get on the main lines, which allowed for that greater difference. And yeah, you obviously saving on the cost there as well. And this allows all the way along that 1.5 meter spacings, allows for exit points at every single pedestal for staff working on the metro car to get out from underneath at any pedestal, rather than having to go to specific points along in the case of any emergency.
Okay,
I'm not sure exactly what the cost saving was, but it certainly would have been a cost saving in there. But that'd be my civils colleagues that would better understand that, unfortunately.
No, thank you for that.
No worries.
Ryan, you had your hand up. I don't know if you've still got a question.
I'm sorry, no, I put my hand up just on that last question, but Alex, I wasn't needed, so put it down again.
Right, thank you. All right, Richard Wells has got his hand up.
Yeah, hi. Sorry, Alex. I joined the presentation a little bit late, but
No worries.
did you use? Obviously, there's lots of stages and it's pretty complex.
Mm-hmm.
Did you use 4D modeling, or was that considered, or was it just a timescale issue?
Timescale issue.
Yeah,
Mostly, yeah. There was a depot flow done for the stages to check the in and out capacity of the depot within the stages, and that did lead to adjustments and capacity of stabling. So that was analysed as part of the staging process. But yeah, it was the time constraints. It was a very fast. Very fast program.
No, just because you'd modelled it all in 3D, I thought it might have been a link in there. And did you have? We did not quite the scale of this, but a depot down in Canton, and ridiculous timescales. But we had the freedom to kind of make changes to the layout. Was that something? Did you have any? Was that even discussed, or was that just an absolute no-no because of the ongoing operation?
The changes to the layout were sort of constraint. You couldn't really make any additional changes. We squeezed the absolute maximum space out of the site and got the maximum capacity that you could for stabling. When you factor in the requirements for signalling, depot protection, maintenance, and OLE setbacks for those things, we'd squeezed out as much space as we could, so there was no real leeway to move anything anywhere else without major civils works of putting in new retaining walls and things like that, which was further constrained by something that I didn't mention earlier on. But there's a high voltage cable that runs within the embankment along the south of the site, which sort of put a stop to any potential plans to move do earthworks and create a little bit more space at the south. So heavily constrained by the tightness and the fact that
it was maxed out.
It was maxed out. Yeah,
similar thing for cable. in embankment. So yes, look, that does stop things in the tracks. Very good. Thank you.
Thank you. Any more questions from anyone? I thought there would be at least one about serviceable F-27s from somebody. Anybody? I'll ask the question. How did you do with your serviceable F-27s? How easy was that? Was it easy to source? Did you have some to hand?
It was part of a construction discussion with the installation contractor. So they highlighted having a large stockpile, which led to the carbon discussion. So, and with them being in good condition, it led down looking into the carbon cost saving of using those sleepers instead of the new G44s, and it was a positive net gain there. So yeah, we
so is this on Metro? Do they have a large stockpile of F-27s? Is that what you're saying?
It's not the Metro, it was the installation contractor.
Oh right. So
yeah.
Where did they get them?
I'm not sure.
We're searching for F-27s. I'm curious. Did they use all of them? Because I could only find 200 recently when people were asking.
Well, this was, we're talking a couple of years ago now. So, and it was combined. So it's not all F-27s. There's F-40s as well. So, but yeah, that was part of it was the initial carbon saving cost as well that sort of led to the agreement rather than just than anything else. Yeah.
No. Well, really good that you've done that.
There's quite a few of the sort of sustainability savings that we looked at, but they're part of the civils pack, and I'd leave it to my civils colleagues to discuss those, I think, rather than and focus on the track aspects. Yeah.
Well, I'll be interested in knowing what you have done, Alex, just so we can share with others. Any other questions? Okay, I think we'll probably bring that to an end today. Alex, thanks a lot for coming on today, and I think it probably was a little bit short notice. You give us a good overview of what the scheme was. Maybe the next one could be a bit more detailed. I think it's probably what I say if you want to do it justice, because it does look like it's a really interesting scheme you've been involved in.
I lived and breathed this scheme along with Ryan, who's on the call, for I think the best part of 4 years, and I could talk all day about it. So happy for a longer presentation at some point in the future. Yeah.
Okay, maybe worth referencing that in. Okay, all right. Virtual applause. Thanks again. Virtual or physical applause, whatever you want to do. I don't know how it works these days. But we're going for virtual.